Hi, this is Chong Kim, and we're going to write chess in Ruby. So let's begin. So we're going to create a gem file, and it's just going to have the basic RSpec and debugger. We run the bundler, and when this is done, we're going to create our directories, lib and speclib. And we're going to start with the test, chess spec. Okay, so first, let's require the chess library, and PO is going to be create an abbreviation PO for position. And all right, so let's think about some of the properties. So board is going to look like this: dashes, 64 of them. It's going to be white turn. En passant is going to be nil. Castling, it's going to be king, queen, king, queen, white and black. Half move, it's going to be 0. Full move is going to be 1. And we're going to set this up so that when we save, it'll automatically run RSpec. Okay, so the first error is that there's no file, which is what we expect. So we're going to create the file chess, and class is position. Okay, and we need to create the accessors. For board, turn, en passant, castling, and half move and full move. Okay, and we need to set the values. So board is going to be dashes, 64 of them. Turn is going to be white. En passant is nil. Castling is going to be the set king, queen, king, queen. And half move is 0, and full move is 1. Okay, everything passed. So then we go back, and what we eventually want is to be able to set up a board. So it's a class method, and it'll look like this: position of rook e4, and then for black pieces, let's say bishop e1 and a pawn on e2. Okay, so given this, let's see, SJS subject. Okay, so subject of e4, that's going to be a rook, and e1 is going to be a black bishop, so it's lowercase b. And for e2, it's going to be a black pawn, so lowercase p. Okay, and undefined method, so let's go create it. So it's a class method. Takes a string and creates a position, creates a new one, and returns the position. But what it's going to do is it's going to take the string, split it, and for each one it's going to see, when it sees a pattern that looks like a piece, so rook, knight, bishop, queen, king, question mark, because it may not be there. If it's not, then it's considered a pawn. Okay, and the coordinates 1 through 8. Okay, great. When it's this, then we want to set the board position. So position board is going to be, actually we have to index that. So we need to convert that to an index of the second argument, the second capture. And we're going to put the first capture, but if it's not there, it's going to default to a pawn. Then we're going to send a function to it, and that function is uppercase, so for white pieces. But when you see 2 dots, then the function is going to be downcase for black pieces. All right, so this should take care of this, and undefined method to IDX. Okay, so we need to create a chess helper here, and to IDX. So to IDX of a number is just going to be that. To IDX of, let's say, for example, A8 is going to be 0. Let's get rid of this quote here. And H8 is going to be 7. And the last area is H1, and that's going to be 63. It's the last square. Okay. One other thing that we want to be able to do is to say that this is going to be a turn, so black. So we'd say the turn is going to be black. Okay, uninitialized constant chess helper. So let's go back, and it's a module, so chess helper. And we create a function to IDX, and it takes in some square. And if it's already an integer, so if square is already an integer fixed num, then we're just going to return it. Otherwise, we're going to do the calculation. So we take the first character, the ASCII value, and take away the A from it. And so we end up getting some value. And plus, we get the ASCII value for 8, subtract the second character from it, and we multiply that by 8. And that should give us the coordinate. Undefined method to, okay, the reason why is because in our RSpec file, we need to include chess helper so that the functions are available to everybody. Okay, so strings can't be coerced to fixed num, so it's on line chess 4. So 4. Okay, so let's see what went wrong here. Oh, that's because we forgot to convert this to an ASCII value. All right, so wrong number of arguments, 2 for 1. Okay, so that's because we want to also be able to take the arguments and just pass it into the constructor. Okay, and this should fail. And so we can write a little test for that. So for the position, new, it should take args. So position, new, and let's see, white, black. And turn, actually, we're going to write it a different way. So position, new, black, the turn should be black. And we can do it another way, which is give it a hash. So the turn is black, and that, and then if we get the turn of it, then it should be black. All right, wrong number of arguments. And then now we can go back to initialize and actually set this. So we have options, the options. Defaulted to an empty hash, and ops is equal to, this is turn is equal to ops. So if the ops is a symbol, so it's not a hash. So if it's a symbol, then we want to just make a hash out of it. So now that we have that, we can use that value. So the turn, we're going to, if it's not there, then we're going to default to white. For en passant, we get the en passant. We misspelled this, so this S. Okay, and ops of half move, ops of full move. All right, Okay, so now we're getting undefined method for brackets for an instance method. So let's create an instance method. Okay, and it's expecting an index, and if it's not indexed, we'll convert it. So we'll fetch the board element to index of IDX. Okay, so everything passed. All right, so far so good. So we're able to set up a position. Now we can actually do our first test for find. So actually, let's break this up into two parts. These will be legal moves, moves that we expect, and illegal moves where it's bad moves. So we can start with a rook. So rook, find a rook that is able to go to e2, and that should just give us e4. And if I say find a rook that can go to e2, but there is something in the way. So for example, there's like, actually, I'm just gonna take this out and just have it all in one place. So okay, you have a rook, and there's a piece in the way. So let's say, for example, there's e3, and you say find a rook that can go to e2. Well, you can't, so it should be empty. What if there are two of them? So if you had a rook on e4 and a rook on e1, and you say find a rook that can go to e2, then that should give us both e4 and e1. And if I say there's a rook on e4 and a rook on d1, and d1 cannot go to e2, so we say find a rook that can go to e2, and that'll give us just e4, because the one on d1 cannot get there. Okay, so for okay, and we shouldn't be able to capture our own pieces. So if I have a rook on e4 and a pawn on e2, and I say find me a rook that can go to e2, that should give me an empty list. Okay, so let's see. So we have a rook that's you can't jump over pieces, you can't take your own pieces, you can't do some illegal moves. All right. And let's see if there's any other situations. Okay, no. So let's go to the bishops. We don't have to retest all these other ones. We can just check for legal and illegal moves. So bishop on e4. Actually, let's start with a knight. Knight on e4. That should be able to go to c3. Okay, so that should say e4. And a knight on e4, it can't go straight, so e2 is out of the question. And let's see some other things that a knight can't do. Well, what it can do is if you have a knight on e4, you can jump over pieces. So let's say that you have a whole line of pieces on d3, d2, d4, and d5. And so the question is, can you find a knight that can go to c3? And the answer is yes, it's located in e4. Okay. All right, so let's see. So we have some knight conditions now for black bishop. So for this scenario, let's make it a black bishop. So bishop on e4, and we can say find me a lowercase b bishop that can go to f3, and it should come back with e4. And let's give an illegal move. So if I have a black bishop, oh, and it's black's turn, so just say black, and e4, and it's black's turn. find me a bishop that can go to f4, and this should be empty. Empty. All right, because you can't go to f4, you can't go straight. Okay, so we have the bishops taken care of. We have rook, knight, bishop, queen. So for the queen on e4, it can go straight. So find a queen that can go to e2, and that should be e4. Find me a queen on e4 that can go diagonally. So queen, and let's say a8, and that should also be e4. And okay, so we have. Let's find an illegal move for a queen. So an illegal move for a queen is to go as a knight. So find a queen that can go to an c3. So that's a knight square, and that should be empty. Then for a king, you should be able to move one square. So king e4, find me a king that can go to e3, and that should be e4. And find me a king on e4 that can go to e5. This is like 2 squares away, so this should be empty. Okay, and for the pawns, let's think of some examples. So a pawn, let's say you're on e2. So from e2, you can say find a pawn that can go to e4, e3, just 1 square, and that should just be e2. And if you have a pawn on e2 and say, can you go up 2 squares? And that should say yes, e2. And what about 4 squares? So if I go from here, 3 squares, find me a pawn that can go to e5, and that should be empty. Okay, and if you have a pawn on e2 and there's something in the way, actually we've taken care of that situation with the rook. Okay, actually we haven't taken care of another situation, which is taking a piece. So for the rook, if you have a rook on e4 and a black piece on e2, then you say find me a rook that can go to e2, and that should be e4. Okay. Let's see, and we should also put in here that you can't capture your own piece. So if the pawn happened to be on e2, then and you try to go to e2, then it should be empty. So you can't jump over it, and you can't take your own piece. Okay, so all right, so let's. So we have capturing taken care of, and we want to be able to say the pawns are a little bit different because they don't capture in the direction that they move. So if there is a pawn on e2 and a black piece on e3, and I say find me a pawn that can go to e3, basically taking the piece, and that should result empty because you can't do that. But you can take diagonally. So if you have a position where you have it on e2 and the black one is actually on f3 instead of e3, say find me a pawn that can go to e2, f3, and that should say, oh, e2. Okay, so another situation is you have a pawn on e2, okay, so you have a pawn on e3 and you try to jump 2 squares. So find a pawn that can go to e5, and this should be empty. Okay, so let's see, another situation is en passant. So you have a position where you have a pawn on e2 no, actually e5, e5, and another pawn on f5, and the en passant happens to be the f6 square. And the question is, find me a pawn that can go to f6, and it should result with e5, because that pawn can take the other pawn en passant, even though there's nothing on f6. Okay, so let's see if this is sufficient. So we have all the pieces taken care of, and the pawns are a little bit tricky, so there may be situations that I might have forgotten. So we have en passant. We can't, when we capture, we can't go diagonally more than one either for any reason. So let's just say that. Position, okay, I'm on e4 and g6. So this is like 2 squares diagonal from it. So find me a pawn that can go to g6, and this should just return empty. All right, so I think this is enough. Save, and undefined method find. So we start with creating the function. Okay, so we say find takes a piece and a target index, actually a target square. All right, so let's handle the case for the rook. So we're going to go through all the indices. So we may need this, so I'll just create indices here. So for the position, indices is equal to all the numbers from 0 through 63. Okay. And we're going to select all these values that pass. It's the source index. And we're going to skip it, okay, under certain conditions. So we're going to skip it if the piece is not the same. So look at the piece from the source, and if it does not equal the piece, then we want to skip it. Okay, another reason that we might want to skip it is if the target piece, I'll just put a target piece over here because it doesn't change. So target piece is equal to target index. Okay, so the piece that's on the target, and we have to define what target index is. Target square. Okay. Okay, we need to just convert that. Okay, so we have the target piece. So the target piece is the same color. So we say the color of the target piece is equal to the color of the piece. Okay, so basically this is saying you can't capture your own pieces. All right, and okay, so the condition, so case when it's the rook, then if the change in x is 0 or the change in y is 0, and we'll say this. Okay, so okay, so the change in x is going to be, I'll just call it xy diff of source index and target index. Okay, so we should get an error, and so first thing is color. So let's just create the color. Color of the piece, actually a pawn, capital P pawn. Color of the pawn should be white. Color of lowercase p should be black. And color of an empty space is going to be nil. All right, so undefined method color. Oh, this is interesting. Oh, right, because we haven't created the function yet. Right, so color of the piece. So, okay, so when it's a capital letter, so if it is A through Z, then it'll be white. And if it's lowercase, then it's black. Okay, and we'll just leave it alone if it's anything else, because then it'll be just nil. Okay, okay, so now we have to define XY diff. So let's see, XY diff. So let's see, XY diff of 0 and 1. That's going to be 1. Actually, the X part is going to be 1, and the Y part is going to be 0. Okay. Missing parentheses there. Okay. And now let's go one level down. So 0 to the next level down would be index 8. So that means that X is going to be, the change in X is going to be 0, and the change in Y is going to be 1. Okay, all right, so we'll see, let's create XY diff. Source index and target index. So we just create target index. This is the X part, so we do a mod of 8, subtract the source, doing the same thing. Okay, and for the Y part, this same pattern, except we divide by 8. Okay, so that gives us the difference. Okay, so okay, so far this looks right, except that the output format is as a number instead of a symbol. So let's see, this is okay, let's go back and okay, so for find, we have a list that's being returned, and we capture that list, and we say that if because we actually do want to have it as an integer, but only if it's entered in as an integer. So we say if the target square is a symbol, then we want to take the list, and for each of the index, we're going to turn that into a symbol. So the square. Otherwise, just return the list. Okay. So now we need to create two square. Okay. So 2 square of E4 is going to be E4, just basically saying the same. And if you give it a string, it's also the same. So this is the inverse operation of toIndex. So toIndex of, let's say, F4, that's going to be equal to F4. All right. No method. Okay, so now we create the function. So 2 square of the index. So the index could actually be okay. So if it's not a number, okay, so we'll just say fixed num for now, and then we just say not. If it's not a fixed number, then we just want to return it and as a symbol. And we do the calculation. We first need the x and y value, and we can do that by taking the index and use div mod of 8. And start with the x, and we're going to add the ASCII value of A, take that whole thing and turn that into a character. Then we do the same thing for the Y part, except we're going to subtract Y from A, turn that into a character. And we take the whole thing and we turn that into a symbol. So, okay, so rook E3. So this is saying you can't jump over a piece. So we need to say that. Okay, so right over here we have to say, and the path is clear from the source index to the target index. Okay, so we need to specify path clear. Okay, so we write a little test for path clear. We do that above here. Path clear. So let's start with a position where we have a rook on e4 and okay, just a rook on e4. Then we want to say path clear, starting from this is expecting number, so e4 to e2, and this should be to be true. And if you have something in the way, let's say at e3, then this should be false. But if you happen to have it at the other endpoint, then it is clear, so it should be true. Okay, so, all right. Oh, something happened here. I think I probably forgot parentheses. One more parentheses, yes. Okay, no method path clear, so we'll make path clear. Takes a source index and a target index, and let's get a path from source index to the target index. And if all of it satisfies all these conditions, so you have indexes and board of index is equal to the empty piece. Okay, so now we need to calculate what the path is. And actually we can probably make it right here, because it should return false if it's not on a diagonal or in a straight line. So it has to be one of those two. So let's get a diff, let's see, dx and dy xy diff of source index and target index. So we have the xy, so if dx absolute is equal to, actually does not equal to dx dy dot absolute. Okay, so that means like it's not on a diagonal, and dx is not 0, and dy is not 0. So basically this is not in a straight line. Then if it's not, okay, then it's going to be true actually, because there's nothing blocking in the way. We're going to just assume that's to be true. And for this, we're just going to step through. I'm going to start from the source, and we're going to step to the target using D steps. And that's going to give us an enumerator, and going to say all of that should be blanked. All right, so we need to find out what D is. And we can calculate D from dx and dy, so we can say dx, okay, what this does is if dx is positive, then it's going to be a 1. If it's negative, it'll be -1. Okay, so then we find the dy part of it, but we're going to multiply it by 8. Okay, so that should be it. There's a little error here. Let's see what it says. Unexpected and. Oh, we forgot to put a 0 here. All right. Path clear. Oh, we forgot to consider one other thing. So we have all of this, but we need to subtract. Actually, this is a Boolean. Oh, we have to say plus d and minus d over here. Okay. Because we don't want to include the endpoints. All right. So we got that to pass. The rook is now able to pass. Now, the knight. Okay, so the knight needs to move. So let's go back to the find. And when it's a knight, then let's take a look at the dx and the dy. If you sort them, that should equal 1, 2. Okay, now let's take a look at the bishop. Then the same test, the dx and dy should be equal, the absolute value. Okay, for black bishop. So we want to say upcase here, so it also works for black bishops as well. Queen. Okay. When it's a queen, then we can take the bishop rule and the rook rule, combine them together. Okay, now the king. When it's a king, then dx and dy, the absolute value of those. The maximum has to be less than or equal to 1, so it can't go more than 1 out of its range. Okay. I think that test is wrong. Yeah, that test looks wrong, so it's 65. So 65. Oh, it says 65, but oh, it's over here. What's it saying? It's 68. Okay, 68 over here. So king e4 going to e5. Let me see. Why would it be empty? Oh, what I wanted to do is jump 2 squares, and okay, so that'll jump 2 squares. All right. Do I have a case where this is a legal case because this just moves 1, and this jumps 2? Okay, so that's what I want. All right, so that's good. So now we're doing the pawns. So for the pawns, it's just moving 1 square. Okay, so the pawns are going to be a little bit more complicated. So I'm just going to break it up in 2 lines over here. So moving 1 square, well, the dx is going to be 0, and dy is going to be, okay, depending on what color you are. If you're white, then it moves -1. Otherwise, it moves 1. Okay, and I'll just put a little note here saying that this is for move 1 square. Okay. Okay, so we need to create a function white. It's a very simple function. So if the turn is white, then you return the white value, otherwise the black value. Okay. Now the pawn is going 2 squares, so let's do that. Or dx is equal to 0, and dy is equal to -2 or 2. And this is move 2 squares. All right. Okay, so it goes from e2, and there's a pawn on e3, so basically you can't you can't capture a piece. That's what it's saying. Okay, so let's see that. We have a condition over here, and we'll say that, and there's nothing, and it has to be an open square. So the target piece should be a blank. Okay, so it should be an open square. Okay, so next one. So from E2 to F3, so it looks like you're capturing a piece. Okay, so capturing a piece. So let's handle capture a piece. Okay, so what does that look like? Actually, we need to put an OR here. Okay, for capturing a piece, we start with dx is equal to the absolute value, actually. So it can be coming from either side, and dy is equal to just one square movement, and the target piece is not empty. Okay, so that should, okay. All right, so now we have a pawn on E3, and you want to move up 2 squares, but that should be allowed. Okay, so moving 2 squares, this should only happen if you're in the home row. So we can say that the y part of this, which is the source index divided by 8. So if you're white, then it should be a 1. Actually, not a 1, 6. And if you're black, then it should be 1. Okay. All right, so E4, E5. Oh, so this is en passant. So you have the en passant flag there, and so when you capture, okay, so let's create OR, and it's the same thing as a regular capture. So dy is equal to white. Okay, now the target piece, actually the target index is equal to the en passant square. Actually, it's not the index. It should be the square. And, well, actually, the square, we're not guaranteed that it is going to be a square, because when it comes in, it could be an integer because it gets converted here. So we'll just wrap this in a to square. Okay, so if it happens to be the en passant square, then this is en passant, capturing en passant. All right, so everything passed. So that means that, looking at this, we have piece movement, where, well, it's able to find the pieces, but we still have to do validation of the move to make sure that the king isn't in check, and you're not able to castle through check and to handle castling as well. So so this is it for this part, and the next part we're going to do chess moves and generating all the possible chess moves from a given position. So stay tuned.